You are welcome to our class. This is the fourth class on this topic, number-based system. So, in the previous class, we talked about converting from base 10 to other base. Now we are going to talk about converting from other bases to base 10. So, how do we go about it? So, if we are converting this, let me just break this into two. That 101. This thing can be rewritten as 101 plus 0.10101. So we are going to take this one by one. Converting this to base 10. So let me quickly use this as a reference that let's say this is 21 now in the normal base 10 system that we have been familiar with. So we are going to talk about the place system of this. We are going to say that this one is a unit. So that means that there is 0, 10. 0, 10. That is 10 raised to the power 0 is present here. And we know that 10 raised to the power 0 is 1. So that means 1 times 1 is 1. We have units. But this one means that there is what? 1 10 here. That's why it is 20. That is 2 times 10 will give us 20. Because 1 10 is present. That's why we call this one 10. Why this one is unit. Now the same thing goes for here. So because it is in base 2, the first letter here there is no 2 present there. The second figure rather there is 1 2, and the third figure there is double 2 present here. So let's put it on top of it. 1 2. So 0 2 is present, 1 2 is present, and double 2 is present here. We are now going to expand it like 1. This means that 1 times 2 power 2, because there is double 2 present, plus 0 times 2 power 1 plus 1 times 2 power 0. So 1 power 2, 1 times 2 power 2 is 4. 0 times 2 power 1 is 2. And then we have 2 power 0 is what? 1. Anything raised to power 0 is what? Is 1. Let's not forget that. Now, we are now going to say 1 times 4 is 4. 0 times 2 is 0. 1 times 1 is 1. So to give us 5. That is in base 10. Don't forget. Which means 101 in base 2 is equals to 5 in base 10.
What's it better?
So that means we have solved one part of the question already. Now it is left. We are left with 0.10101 base 2. So, but this is after decimal point. This one is different. Negative 1 is present here, which means inverse of 2, 1 2 is present. Inverse of double 2 is present here, and the inverse of triple 2, the same thing 4 and 5 for this. Now let's expand the same way we did that. We have 1, 0 is 0, so we don't really need that. 1 times 2 raised to the power minus 1 plus 0 times 2 raised to the power minus 2 plus 1 times 2 raised to the power minus 3 plus 0 times 2 raised to the power minus 4 plus 1 times 2 raised to the power minus 5. So let's now head. Now in indices, when you have something like when something is to the power of a negative number, this negative itself can be written as 1 over. And then these 2 and 1 that is on top can now put it under it. So if I write 3 raised to the power minus 2 now, I can just write is equal to 1 over 3 power 2. So the same thing we are going to do it here. This can be written as 1 over 2 power 1 plus 0 times 1 over 2 power 2 plus 1 times 1 over 2 power 3 plus 0 times 1 over 2 power 4 plus this one 1 times 1 over 2 power 5. There we have 1 times 1 is 1, 2 power 1 is 2 plus this one is 0. You know, 0 times 1 is 0. 0 divided by 2 power 3 is still 0. So This one is 1 times 1, and 2 power 3 is 8. This one is also 0, the same thing we did here, plus 2 power 5 is what? 32. Now, if we are to find the LCM here, is 32, right?
Okay.
So 2 in 32 is 16. 16 times 1, 16 plus 0. 8 in 32, 4. 4 times 1, 4. Plus 0 plus 32 in 32, 1. 1 times 1 is 1. So if we add the 16 plus 4, 20 plus 1. So which means it was 21 over 32. So to finish the question, to finish solving the question, we can now say that 101.10101 is the same base 2, is the same thing as, don't forget that we got 5 for this part, and then we just got 21 over 32. So they are all in base 10. So we have converted it like that. So secondly, let's quickly do the second one, which is 34.52 base 8. So I won't take much time now. So we know that there is 0 8 present here, 1 8, and negative 8 power of 1 and negative of 2 here. Now let's expand. We have 3 times 8 power 1 plus 4 times 8 power 0 plus this one can also be done as 5 times 8 power minus 1 plus 2 times 8 power minus 2. You can see that I did not break it now. I did not separate it the way I did the first one. You can also do it like this. So we have power 8 power 1 is 8. 8 power 0 is 1. Anything up to the power of 0 is 1. Don't forget that. And then we will write this as 5 times 1 over 8 power 1 plus 2 times 1 over 8 power 2. So 3 times 8 is 24. 4 times 1 is 4. And then 5 times 1 is 5 over 8 power 1 is 8 plus this one is 2 times 1 is 2, 8 power 2 is 64. So for this, don't forget this is not related to this, so we treat this separate. 24 plus 4, this is what? 28. And then this is what? This is 64. So the LCM here is 64. Then 8 in 64 is 8. 8 times 5, we have 40. 64 in 64 is what? Is 1 times 2, we have 2. So we can now write this is equal to 28. 40 plus 2 is 42 over what? 64. So 2 here, 21. 2 here, 32. So we can write it as 28 whole number 21 over 32 in order to solve this question. So that is it. Now for the third question, I give it as a take-home test for everybody. So try and do this. But don't forget this B. We talk about it that there is no 10. So A represents 10, B represents 11, C 12, and D 13, which means this is 13, while this is 15. F, B, don't forget, is 11. So you just put it instead of writing B here, B times 16 raised to the power minus 2, you just write 11 times 16 raised to the power minus 2 to solve it. So I'll be looking out for your answer in the comments. Thanks.